This is my fifth video lesson on Unit 6B. In this lesson, we'll be learning about stoichiometry. Go to page 15 in the class packet. Motivation. Given this chemical equation, we have N2 plus 3H2 gives us 2NH3. If I have 28 grams of N2 and excess H2, how much mass of NH3 can I make? This is an example of a stoichiometry problem. At this point, you learn every step in the procedure already. You just have to put them in order. These are the steps: finding the GFM of a substance, converting units to moles, and mole ratios. So by looking at this question, which one will we do first? So first, you're given 28 grams of N2. You must convert it to moles first. So once you do that, then you do a mole ratio between N2 and NH3. That will give you the moles of NH3. Then you find the GFM of NH3. Then you convert it back to grams. So in this lesson, we'll go over the procedure as well as different methods in solving stoichiometry problems. Learning target. At the end of the lesson, I'll be able to solve stoichiometry problems given either the mass, mole, volume, or molecules. Homework will be number 5, which will be a Junipod based off this lesson. Most stoichiometry problems follow a set sequence which revolves around the mole. The general strategy is quantity A converts to moles A, which converts to moles B, which converts to quantity B. Quantity A is what's given in the problem. Quantity B is what you want. The overall strategy is convert quantity A to moles, use the mole ratio to get moles B, convert mole B to quantity A. Quantity A and quantity B can have units of mass, volume, or number of atoms and molecules. In this general strategy, the most important step is the mole ratio. We can only compare the two substances through mole ratio. Sometimes quantity A or quantity B have units of moles, so you have one less step in the general strategy. There are 4 scenarios that you must be able to do for the regions. In all these scenarios, you're converting from quantity A to quantity B. The first scenario is scenario A. You're going from mass to moles or vice versa. In B, you're going from mass to mass. In C, you're going from volume to mole, mass, or volume. And the last scenario, you're going from molecules and atoms to mole, mass, volume, or molecules. Typically on the regions for stoichiometry problems, scenario A and scenario B are asked 95% of the time. C and D are much more rare. In this lesson, I'll show you 2 methods along with some graphic organizers to help you solve stoichiometry problems. The first method is the 3+ method, which is a beginner method. The second method is the bridge method, which is a more medium level method. The first method is the 3+ steps method, which is a beginner method. It's based off the general strategy. As you can see, there are 3 steps to the strategy. There might be more steps if there are more conversions. So step 1, you convert whatever you have for your quantity A to moles. Then you do a mole ratio in step 2 from mole A to mole B. In step 3, you do a unit conversion to the unit you want for quantity B. Always include units and double check your answer. I will show you 3 diagrams to help you use this strategy. Each diagram is a different version of the same thing. The first diagram is this one. Imagine there are 2 cities, the Great Divide and Rabbittville. You always start at the Great Divide and your goal is to get into the city of Rabbittville. The goal is to go from the Great Divide to Rabbittville. It's only one way, from left to right. So the step 1, you're either given mass, particles, or volume in the problem, and your goal is to convert to moles. Step 2, you're going to do a mole ratio. And step 3, you're going to convert it to the quantity or the unit that you want. So the Great Divide means divide, division. Whatever quantities A units are, you are going to divide by the conversion factor to get the moles. Once you get the moles, you do a mole ratio to get the moles of quantity B. In Rabbittville, you'll be multiplying because rabbits multiply quickly. So your quantity B in moles, you are going to multiply by the conversion factor to get the desired unit in the problem. In diagram 2 is a different representation. In step 1, you're given your quantity A in a certain unit. You're going to convert it to moles. In step 2, you're going to do a mole ratio. Then you convert back into the desired unit for quantity B in step 3. This is diagram 3, which is a more detailed version of diagram 1. This stoichiometry map can be found on my website. This map is used to solve stoichiometry problems. A and B are substances. M and N are the coefficients. M is the coefficient of A, and N is the coefficient of B. In the chemical equation, in the problem, you'll be given quantity A in terms of either mass or volume or particles, and you'll be solving for quantity B in terms of either mass or volume or particles. As long as you follow the calculations in the right order in the diagram, you'll get the answer right all the time. Let me show you how to use it. In the question, you'll be given A in terms of either mass or volume or particles, and you're solving for the quantity B in terms of either mass or volume or particles. So to get the moles of A, you have to divide by the conversion factor. To go from mole A to mole B, you have to do a mole ratio, or you can multiply by N over M. N is the coefficient of B, M is the coefficient of A. To go from moles to the unit you want, you multiply by the conversion factor. In this lesson, I'll show you how to use all three diagrams. From the motivation, I'll show you how to use the 3 plus method and use diagram 3. If I have 28 grams of N2 and excess H2, how much mass of NH3 can I make? So using the general strategy, quantity A from the problem represents the mass of N2. Quantity B, which is what we're looking for, is the mass of NH3. So we're going to go from mass of A to moles of A, then to moles of B, then to mass of B. Step 1 is converting mass of A to moles of A. Step 2 is doing a mole ratio to go from moles A to moles B. And step 3 is converting moles of B to mass of B. So we're going to use diagram 3. We are given mass of A, and we want to find mass of B. So the first step is to find moles of A, and we do that by dividing by the GFM of A. So we're going to first do a conversion of moles. So here's the GFM of N2 and NH3. Based on the diagram, to get the moles of N2, we have to do the mass of N2 divided by the GFM of N2. So 28 divided by 28 is 1. We have 1 mole of N2. The next step is to do a mole ratio to convert moles of A to moles of B. To do that, we're going to multiply by the coefficient ratio N over M. 1 mole of N2 times the coefficient ratio should give you the moles of NH3. So to figure out the coefficient ratio, you can look at the chemical equation. N is the coefficient of NH3, which is 2. M is the coefficient of N2, which is 1. So 1 times 2 over 1 will give you 2 moles of NH3. You can also figure out the mole ratio using the traditional method. You set up a proportion, and you solve for the moles of NH3, which is also 2. The last step is to convert the moles of NH3 to mass. To do that, we're going to multiply the moles of NH3 by the GFM of NH3, which is 17. 2 times 17 gives us 34 grams of NH3, and that is the final answer. As long as you follow the general strategy and use one of the diagrams, you should be able to solve every stoichiometry problem in this lesson. The second method is called the bridge method. This is a medium level method. It has a slightly different approach from the 3 plus method. The procedure and example is found on page 17. The bridge method involves setting up the calculations first using a 4 by 2 boxes or bridge. Then after you set it up, then you use a calculator to multiply everything. As long as you set up the bridge correctly, you'll get the answer right each time. This is a medium level method because the difficult part is setting it up correctly. So why is it called a bridge method? Because this looks like a bridge. If I draw the water, you can clearly see that this is a bridge. So when you set up the bridge, you can set up the bridge from left to right. So we're going to use the same problem with the motivation. If I have 28 grams of nitrogen gas and excess hydrogen gas, how much mass of ammonium can be produced? We will be using the general strategy to fill in the bridge. The first column represents quantity A. The second and third column will be the calculations for the moles A and moles B. And the last column is for quantity B. The top box of the first column is always the given amount in the question. The top box of the last column is always the unit you want. So based off the question, the given amount of quantity A is 28 grams of N2 gas. The unit we're solving for NH3 is mass, so that'll be in grams. The next step is to fill in column 2 with the conversion factor of mass to moles. 28 is the GFM of N2. So for column 2, we're going to put in the conversion factor. Which one do we put in? We use a diagonal arrow to figure out. So notice with the diagonal arrow, we're going to put the conversion factor that has grams in the denominator. So that'll be this one over here. For the third column, it's always moles B over mole A. So this is based off the mole ratio from the chemical equation. So that'll be 2 over 1. The next step, we write in the conversion factor for the last column to convert from moles to mass, which is grams. To do that, we're going to write in the GFM of NH3, which is 17 grams over mole. At this point, we completely set up the bridge, so the last step is to multiply everything from left to right. If you notice, if you multiply everything from left to right, the units cancel out. This is how you can check if you set up the bridge correctly. For example, the grams will be canceled out, the N2 will be canceled out, the moles will be canceled out. So notice that the units left over is NH3 and grams, which is the units that you want. So 28 times 1 over 28 times 2 times 17 is 34 grams of NH3. Notice we got the same answer as the previous method. So you can use either the 3 plus method or the bridge method to solve these stoichiometry problems. So pick your favorite one. Each method will follow the same general strategy. For the rest of the lesson, we'll be going over examples of each of the 4 scenarios. So let's start with scenario A, which is mass to moles, or vice versa. Here's the chemical equation. How many grams of ammonium are produced when 1 mole of nitrogen reacts? So I'm going to first use the 3 plus method with diagram 2. Based on the problem, what are we given? We are given 1 mole of nitrogen. And what do we want? We want grams of ammonium. So this is our general strategy. We can go from moles A to moles B through mole ratio, then convert moles B to quantity B in terms of mass. So the first step is to do a mole ratio between N2 and NH3 by looking at the chemical equation. It is a 1 to 2 ratio. Currently, we have 1 mole of N2. So how many moles of NH3? By cross multiplication, we get 2 moles of ammonium is produced. But the question asks for mass, not moles. So we have to convert from moles to mass. If we look at diagram 2, to do that, we have to multiply by the molar mass of ammonium. By using the periodic table, the molar mass of ammonium is 17 grams per mole. 2 moles of ammonium times 17 grams over mole will give us 34 grams of ammonium. So this is our final answer. You can also get the same answer by using the bridge method, and this is the setup of the bridge. Learning check number 1. Given the chemical equation, how many grams of ammonium are produced when 2 moles of nitrogen reacts? Pause the video and resume once completed. The answer is choice 2, 68 grams. So this is how you would do it. This is the general strategy. You're given the moles of nitrogen and you want to find the mass of ammonia. The first step is to use a mole ratio to get the moles of B. Based off the chemical equation, the mole ratio between N2 and NH3 is 1 to 2. Since we're given 2 moles of N2, how much NH3 is produced? So if we cross multiply, we get 4 moles for NH3. The next step is to convert the moles of ammonia to the mass of ammonia. So to do that, we need the GFM of NH3, which is 17. 4 moles times 17 grams over mole will give us 68 grams of ammonia. And that's the answer. Learning check number 2. How many grams of ammonium are produced when 4 moles of hydrogen reacts? Pause the video and resume once completed. So the answer is choice 3, 45 grams. How do we get that? We use the same general strategy. Moles of A to moles of B give us quantity B in terms of mass. Based off the question, we're given 4 moles of hydrogen and we want the grams of ammonia. So we're going to set up a mole ratio between hydrogen and ammonia. Based off the chemical equation, the mole ratio between hydrogen and ammonia is 3 to 2. In the question, we have 4 moles of ammonia. When we cross multiply, we get 2.67 moles of ammonium produced. Now we have to convert the moles of ammonium to mass. To do that, we multiply it by the GFM of ammonia, which is 17. 2.67 times 17 gives us 45 grams of ammonia. So the answer is choice 3. Now I want you to do the rest of the problems in scenario A on your own. Do 1B to 1F. Pause the video and resume once you want to see the answer. So here's the answer to 1B. 22.67 grams of ammonia. And here's the bridge method. For 1C, the answer is 28 grams of N2. And here's the bridge method. For 1D, the answer is 2 moles of NH3. And here's the bridge method. For E is 7.5 moles of H2. And for F, 9 grams of H2 and 42 grams of N2. Scenario B is the mass-to-mass stoichiometry problem. I'll be using diagram 2. Question 2a, we're given the chemical equation of the synthesis of water. What is the total number of grams of O2 needed to produce 54 grams of water? Since we're given mass and we're solving for mass, our general strategy is going to be mass of A to moles of A to moles of B to mass of B. From the question, we're given 54 grams of water and we want the mass of O2. So diagram 2 shows the pathway of the calculation. If you recall, there's 2 imaginary cities in diagram 2, the Great Divide and Rabbittville. You do division in the Great Divide and multiplication in Rabbittville. So you always start off in the Great Divide city and your goal is to move to Rabbittville. So since we start at mass, we're going to divide by the molar mass to get moles. The molar mass of water is 18. So to get the moles of water, we do 54 divided by 18, and that should give us 3 moles of water. Now we have to find the moles of the O2 by doing a mole ratio between O2 and H2O. By looking at the chemical equation, the ratio between O2 and H2O is 1 to 2. We have 3 moles of water, and we have to cross multiply to solve for the moles of O2. We get the moles of O2 to be 1.5. The last step before we go to Rabbittville is to multiply by the molar mass of O2. The molar mass of O2 is 32. If we multiply 1.5 by 32, we get 48 grams of O2. And that is the final answer. You can also solve this using the bridge method. Here's the setup. Check of understanding number 1. Is there such a thing as a mass-to-mass ratio and why? So this is based off the previous question. Notice we set up a ratio using mole and mass. We cannot do that because each substance have a different GFM. So the counting will be off. Learning check number 3. What's the total number of O2 needed to produce 72 grams of water? Pause the video and resume once completed. So the answer is choice 1, 64 grams. Since we're given mass and we're solving for mass, the general strategy is mass of A to moles of A to moles of B and mass of B. We're given 72 grams of water. We have to convert to mole by dividing by the GFM of water, which is 18. So we have 4 moles of water. The next step is the mole ratio between O2 and water. Based off the chemical equation, the ratio between O2 and water is 1 to 2. We have 4 moles of water. Therefore, we have 2 moles of O2 when we cross multiply. Next, since the question is asking about mass, we need to convert the moles to mass. We multiply the 2 moles of O2 by the GFM of O2, which is 32. 2 times 32 is 64, and that's the answer. Learning check number 4. What's the total number of grams of H2 needed to produce 72 grams of water? Pause the video and resume once completed. So the answer is choice 4, 8 grams. This learning check has a similar question to the previous learning check, in which both questions produces 72 grams of water, but instead of asking about the number of grams of O2, it asks about H2. So we're given the same general strategy. We're given 72 grams of water. 72 grams divided by 18, which is a GFM, is 4 moles of water. Next, we do a mole ratio between H2 and H2O. They are 2 to 2 or 1 to 1 ratio. We have 4 moles of water. Therefore, we have 4 moles of H2 when we cross multiply. The next step is to figure out the mass of H2. We do that by multiplying the moles of H2 by the GFM, which is 2. 4 times 2 is 8, and that's the answer, 8 grams of H2. Notice from the previous learning check, we had 64 grams of O2 needed to produce 72 grams of water. So if you add up the mass of the reactants, it should equal the mass of the products. 64 grams plus 8 grams is 72 grams, and that is the mass of water. So law of conservation of mass is observed. So I'm going to do one more question. Question 2b, what's the total mass of water formed when 8 grams of hydrogen reacts completely with 64 grams of oxygen? Since we're given mass and we're solving for mass, this will be our general strategy from mass of A to moles of A to moles of B to mass of B. From the question, we're given 8 grams of hydrogen and 64 grams of oxygen. So they both will react completely according to the question. And what do we want? We want the mass of H2O. So based off diagram 2, this is our general pathway. This question gives you more information than you actually need to solve for the mass of water. You can use either quantity, either the mass of H2 or the mass of O2, and you should get the same answer. I'll prove it to you. So let's start with using H2, which is 8 grams. We first got converted to moles by dividing it by the molar mass. So the molar mass of H2 is 2. 8 divided by 2 is 4. We have 4 moles of O2. Next, we do a mole ratio between H2 and H2O. Based off the chemical equation, the ratio between H2 and H2O is 2 to 2 or 1 to 1. We have 4 moles of H2. We cross multiply to get the moles of H2O. The next step is to go from moles of H2O to mass of H2O. We do that by multiplying by the molar mass of H2O, which is 18. 4 times 18 gives us 72 grams of water, and that is our answer. You can also get the same answer if you use 64 grams of O2 instead of H2. Here's the bridge method setup. If you multiply everything, you will get 72 grams of water. Another easy way to do this is to follow the law of conservation of mass. Since we're given the mass of each reactant, 8 grams and 64 grams, if we add them up, we will get 72 grams of water, which is the answer. So sometimes on the Regents, you can use the law of conservation to answer mass to mass scenario without actually doing the calculation. This can help you save time or check your work. Now I want you to try to do 2C and 2D on your own. Pause the video and resume once completed. So here's the answers. Scenario C is volume to either mole, mass, volume, or vice versa. So let's look at the first question, question 3A. What is the total number of liters of H2O produced when 1 liter of C3H8 reacts completely with 5 grams of O2? Since we're given volume and we're solving for volume, this will be our general strategy, volume A to moles A to moles B to volume B. Based off the question, we're given the volume of C3H8 and the volume of O2, and we're solving for the volume of H2O. This is our general pathway in solving this problem. Since we're given more information than we actually need, you can use either C3H8 or O2 to solve this problem. I will show you that you'll get the same answer by doing both. So let's start with C3H8. So we first have to divide by 22.4 to get the moles of C3H8. By doing this, we get 0.045 moles of C3H8. Next, we do a mole ratio between C3H8 and H2O. Based off the chemical equation, the mole ratio is 1 to 4. We have 0.045 moles of C3H8. If we cross multiply, we get 0.18 moles of H2O. The next step is to convert the moles of H2O to volume of H2O. To do that, we're going to multiply by 22.4, and we get 4 liters of H2O, and this is our final answer. You can get the same answer by using O2 instead. Here's the bridge method setup. If you multiply everything, you will get 4 liters of H2O. Learning check number 5. What's the total number of liters of CO2 produced when 1 liter of C3H8 reacts completely with 5 liters of O2? Pause the video and resume once completed. So the answer is choice 3, 3 liters. So it's the same general strategy. We are given 1 liter of C3H8. We have to first convert to moles by dividing it by 22.4 liters. We get 0.045 moles of C3H8. Next, we do a mole ratio between C3H8 and CO2. Based off the chemical equation, it is a 1 to 3 ratio. If we cross multiply, we get 0.135 moles of CO2. To convert the moles of CO2 to volume, we multiply by 22.4 liters, and we get 3 liters of CO2, and that's the answer. Learning check number 6. What's the total number of liters of CO2 produced when 10 grams of O2 reacts completely with excess C3H8? Pause the video and resume once completed. So the answer is choice 4, 4.2 liters. In the question, we're given mass and we're solving for volume. So our general strategy is mass of A to moles of A to moles of B to volume of B. We are given 10 grams of O2. Our first step is to convert it to moles. To do that, we divide it by the GFM of O2, which is 32, and that gives us 0.3125 moles of O2. The next step is to do a mole ratio between O2 and CO2 by looking at the chemical equation. It is 5 to 3 ratio. If we cross multiply, the moles of CO2 is 0.188 moles. The last step is to convert the moles of CO2 to volume. We do 0.188 moles of CO2 times 22.4 liters. That gives us 4.2 liters of CO2, and that's the answer. Now I want you to finish scenario C on your own. Finish free B to free E. Pause the video and resume once completed. So here's the answers. For free C, free D, and free E. In the last scenario, scenario D, it is molecules and atoms to either moles, mass, volume, or molecules. So let's look at the first question, question 4a. What is the total number of CO2 molecules produced when 1 mole of C2H6 is consumed? Since we're given mole and we're solving for molecule, our general strategy is moles of A to moles of B to molecule B. Based off the question, we're given 1 mole of C2H6. So what do we want? We want the molecules of CO2. So the first step is to go from moles of A to moles of B through a mole ratio. From the chemical equation, the mole ratio between C2H6 and CO2 is 2 to 4 ratio. Since we have 1 mole of C2H6, we have 2 moles of CO2 when we cross multiply. The next step is to go from moles of CO2 to molecules of CO2. To do that, we're going to multiply by 6.02 times 10 to the 23rd. 2 moles of CO2 times 6.02 times 10 to the 23rd gives us 1.2 times 10 to the 24 molecules of CO2. You can also get the same answer by using the bridge method. Learning check number 7. What is the total number of CO2 molecules produced when 90 grams of C2H6 is consumed? Pause the video and resume once you complete it. So the answer is choice 4. So from the question, we are given mass and we're solving for the number of molecules. So our general strategy is mass of A to moles of A to moles of B to molecules of B. So we're given 90 grams of C2H6. We must first convert it to moles. So the GFM of C2H6 is 30. So the moles of C2H6 is 3. The next step is to do a mole ratio between C2H6 and CO2. From the chemical equation, the mole ratio is 2 to 4. Since we have 3 moles of C2H6, we have 6 moles of CO2. The last step is to convert the moles of CO2 to molecules of CO2. We're going to do 6 moles of CO2 times 6.02 times 10 to the 23rd, and we get 3.6 times 10 to the 24 molecules of CO2, and that's the answer. Learning check number 8. What is the total number of CO2 molecules produced when 22.4 liters of C2H6 is consumed? Pause the video and resume once you complete it. In the question, we're given volume and we're solving for molecules. So the general strategy is volume of A to moles of A to moles of B to molecules of B. In the question, we're given 22.4 liters of C2H6. We must first convert it to moles by dividing by 22.4. We have 1 mole of C2H6. The next step is a mole ratio between C2H6 and CO2. By looking at the chemical equation, the mole ratio between C2H6 and CO2 is 2 to 4. Since we have 1 mole of C2H6, we have 2 moles of CO2. The last step is to convert the moles of CO2 to molecules of CO2. We do 2 moles of CO2 times 6.02 times 10 to the 23rd, and we get 1.2 times 10 to the 24 molecules of CO2. Now I want you to finish scenario D on your own. Do 4B to 4E. Pause the video and resume once you want to see the answers. So here's the answer to 4B. Here's the answers to 4B with the bridge method. Here's the answers to 4C, 4D, and 4E. So this concludes the video lesson for today. Remember to do the Junipod homework.